Okay, so I'm going to start off with the table of formulae for the polygons. Okay, now I need you guys to write this down, take screenshots. Some of you probably know these pretty well. This is just for you to have a little bit of an information sheet that you can refer to if you do not remember the formulas for area. All right, guys. So let's get going. The first one would be your square. And of course, that would be side squared. And that's only because all the sides are the same length anyway. So it's actually very similar to the one for rectangle because that's your base times your height. It's just that in this case, your base and your height are the same. So you just say one side squared. Makes sense? And then the second one is your rectangle, which we just spoke about. Length times breadth and base times height are the same thing. Your length would be your base, which is your longest side, the one that is at the bottom. And then your breadth would be the height, which is the one on the side, on the right-hand side. Now, the next three shapes have something very special about their heights. Can anyone tell me what that thing is that is special about the height of a triangle, trapezium, and parallelogram? I know it just says height in the formulas, but there is something very special about those heights that we have to keep in mind. What is that? Thank you, Spa and Leachilwe. You have to use the perpendicular height for these three. Okay, you have to use the perpendicular height because they all three have what we call a slanted height. That is this one. Okay, the one that is not necessarily straight. We do not want to use those when we are working out the area. You always look for the perpendicular height. So when we look at the triangle, the formula will be half of the base times your perpendicular height. Okay. In a trapezium, we know we have one set of parallel sides. So the formula for the area is the sum of those parallel sides times a half times the perpendicular height. And then, of course, lastly, your parallelogram. That's just base times height. It looks very similar, or it actually looks identical to the rectangle. The only problem is we're not using the breadth. We're not using the slanted height. We are literally going to look for the perpendicular height. And most of the time, if you don't have that perpendicular height, you can find it because you can have a triangle, right angle triangle over there, and just figure out what that side is using Pythagoras. Okay, so let's get started with one that is relatively simple. Triangle ABC is given. Work out the area. So the first thing I'm going to caution you to do, especially people who know these formulae well, you guys like skipping the formula and just writing numbers. You will lose half of your marks if you do that because we allocate marks for the formula. So you cannot just skip writing the formula and go straight to numbers because you will lose half, or you will lose at least 1 mark if you do that. Okay, so the area of a triangle is half of the base times the perpendicular height. What is the base for this specific triangle over here? What is the base for my specific triangle that we're looking at here? That is 4, and my perpendicular height of 4, and the perpendicular height is 5. Great. Now let's work out our area. Let's work out our area here. Half of 4 times 5. What is that going to give us? That will give us 10. And what's my unit for area? Our unit for area is squared. Okay. It's always squared. Just think about if you are doing the laws of exponent. We are multiplying 2 dimensions here, which actually have a meter. It's not just 4 times 5. It's a 4 meters times 5 meters. And in our algebra, we said if you have variable times variable, what happens to the exponent? What happens to the exponent when we are multiplying and we have the same base? Does anyone remember? We add the exponents. So it's going to be 1 plus 1, which is why we end up with meters squared. Does that make sense, guys? Can I have a thumbs up, thumbs down on this question? It's important that you remember or find a way to remember the squared that makes sense. So you're multiplying a meters times a meters, so it's meters squared. When you're multiplying centimeters times centimeters, it is centimeters squared. What happens in volume? How many of those are we multiplying? How many of those units in volume are we multiplying? 3 of them, which is why your unit will end up being meters cubed. Is this making sense, guys? I hope so. Okay, let's look at triangle DEF. Do we have enough information to figure out the area of triangle DEF? No, what's missing? The base. And how are we going to find it? We're going to use Pythagoras because we have a right-angled triangle. So let's get going. DE squared plus EF squared is equal to DF squared. Great. Now DE, that will be my 4 squared, and EF is what we're looking for. So I don't have a number to substitute here. It's just EF. But DF we have because it is 5 squared. Now to get EF on its own, what do I have to do? If I want to get EF alone, I have to move this 4 over to the other side. That was a horrible curve. It was supposed to curve, guys. Because then I'm going to end up with, what's 5 squared? 5 squared is 25 minus this 4 squared, because yes, it is your inverse operation, and 4 squared will give us 60. So then EF squared is 9, and my inverse operation for squaring, we're not answering my question. What is the inverse operation for squaring? What do we call it? A square root. Thank you. We square root both sides. Therefore, EF is equal to 3 meters. So this is 3 meters. Then you can move on to the area. So area equals half of base times perpendicular height. We just worked out our base, which is 3, and our perpendicular height is which one? Our perpendicular height is how much? That would be 4. And half of 3 times 4 gives us a final answer of 6 meters squared. Okay, thumbs up, thumbs down on this one. Okay, now let's look at a shape like this. What is this whole shape called? It actually has a name. What is this entire shape called? It's not a polygon. Well, it is a polygon, but it has a special name, right? A pentagon, because it has 5 sides. 1, 2, 3, 4, 5. Great. Now, what do we do in cases of pentagons? Do we have formulae for the area of shapes like pentagons? Ah, you're going to say a house. Ah, I'm defeated. No, we don't. So what do we do in a case like this? What do we do in a case like this? We separate it into two different shapes. So we're going to have what's the shape at the bottom that I'm highlighting in yellow? How do you know it's a rectangle and not a parallelogram? It's 100% a rectangle, but how do you know it's a rectangle and not a parallelogram? Because of the 90 degrees. Nice, guys. The 90-degree angles make it a rectangle. And then at the top, of course, we're going to use the formula of a triangle because we have a triangle. Now, I want us to start at the bottom. Okay. Formula for area of a rectangle. Can I have it, please, in the chat? Area equals length times breadth, or breadth times height. Doesn't matter. Okay, I'm going to stick to breadth times height because that's the one I gave you in the formula above, formula sheet. What is my base? Not breadth times height, base. Oh my gosh. What is my base in this case? 8, and your height 6. So my area of the bottom part is, the area for the bottom part is 48 meters squared. Great. So we've sorted out the yellow part of this. Now we need to sort out the triangle. Okay. The triangle. Now, do we have enough information to figure out the area of that triangle? What's missing? Besides the conversion, what's missing? What's missing besides the perpendicular height? Okay, the perpendicular height. Now, how am I going to find that perpendicular height that is missing? Pythagoras, yes, we're going to do Pythagoras. So I think it's a good idea. I saw someone named this E in the, no, not E, A, B, C, D, E. I'm going to name this F because we can only do Pythagoras on one of the small triangles. Do you guys agree? We can only do that. Now, how long is the side BF? Look at the F that I just added now. We all agree it's 4. How do you know it's 4? You divide it by 2. Are we allowed to assume that those two sides are equal? Are we allowed to assume that those two sides are equal? No. They are in fact equal, but in mathematics, are we allowed to assume? No. And because you guys are the standard class, I want you guys to tell me how we're going to prove that BF is equal to EF. There is a way that we can do it. If this question was only out of like, let's say 4 marks, then yes, you can assume, right? Yes, you can assume. But let's say this question was out of like 9 marks, which I would make it, right? I would make it out of 9 marks because how do we, where does it show? Someone said it shows at the top. Where does it show that BF is equal to EF? It says AB is equal to AE. It doesn't say anything about BF is equal to EF. Do you guys agree with me? Are we with me? Yes, it doesn't say those sides are equal. So how do we prove without a doubt that those are equal? Think back to geometry of two-dimensional shapes. I have triangles. I have 2 triangles. There's a way that I can prove that these are equal. Anybody finding the magic word I'm looking for? Yes, Kanye. You can prove those 2 triangles are congruent. We can prove congruence. And luckily, we actually don't have to do that much work because everything is filled in here for us. I know, I like that clap. Major shout out, Kanye. Major shout out for figuring that out. Okay, so we can prove these two triangles are congruent. So I'm going to go ahead and write, because there's so many triangles here, I'm going to say in triangle ABF and the second one, which is triangle AEF. Now let's prove. Okay, do we remember our conditions for proving congruency? Do you remember how we prove congruency? Side, angle, side. What's the other ones? I'm going to write them small here. Side, angle, side. What else? Side, side, side. What else? Welcome, Alice. 90-degree hypotenuse side. Okay, so out of the stuff that I've written here. Oh, yes, and side angle, angle. Out of these I've written here, which one do you think will be the easiest without us having to work stuff out? The information is literally given to us. Yes, Kanye. Do you guys agree? We can see that there's a 90 degrees in the middle, right? If this is 90, then the other side is also 90. Okay, so I'm going to say A, F, B is 90, given. We're not there yet, Spa. We're not there. We don't even know if these guys are congruent. Remember, you can't start one thing and then go. So we're just going to first prove them congruent so that we know that this is 4 and this is 4. And then I'll convert, okay, just before we use them. And then AFE is also 90. Is my reason going to be given in this case? Is my reason going to be given for this case? No, what's your reason going to be? Why am I saying AFE is also 90? It is not being proven. There we go, Leachile. It is angles on a straight line. On a straight line. Great, I have the 90 degree. Great, hypotenuse AB is equal to AE. And what is my reason for that? That was definitely given. Okay, they wrote it down for us. They gave us these little kolikis. Okay, and then the last one, which side are we proving equal? Which side is equal in the two triangles? Which of the sides are equal to one another? Yes. Side AF is equal to side AF. It is a common side. Great. Therefore, triangle ABF is in fact the exact same triangle. So it's very equal or congruent to AEF. And then I can say, therefore, BF is in fact equal to EF, which means they have to equal 4 meters. Okay, I'm going to write it in a different color because now the colors are starting to get with my head. 4 meters and 4 meters. Great! Now we get to the conversion. How do we get to 500 centimeters to meters? 500 centimeters to meters divide by 100. And this will give me 5 meters. Whew, isn't that wonderful? So let's figure out the area of this triangle. Area is half the base times the perpendicular height. Our base is how much? Our base for this triangle is how much? No, how did I get there? We didn't even find the height. Guys, nobody's like, no, wait. We need to do Pythagoras. We don't know what AF is. Okay, we need to do Pythagoras. So AF squared plus BF squared is equal to AB squared. Great. AF is what we're looking for. So I'm going to keep it that side. plus BF, which we now know is 4 is equal to 5 squared. This is the same Pythagoras we just did the other, like right above. Do you guys see that? It's literally the same thing because it ends up being 25 minus 16. Was the other side also called AF? I feel like it was. Therefore, side AF is equal to 3 meters. I'm pretty sure it was. Oh, it was EF. Okay, close enough. Close enough. Okay, now we can say area is equal to half of the base times perpendicular height, which is equal to half of. Now I can ask you, what is the base? Hi, Jason. Welcome. The base is 8, and our perpendicular height is 3. And what is half of 8 times 3? We have a 12 meters squared. And there we go. I don't know why I zoomed out so much. There we go. Can I get a thumbs up, thumbs down on this one? This was such a lovely question. I would use this. Pusisiwe, is that a hands up? Yes, it is. It looks like a hands up. Pusisiwe, you can unmute. Y is triangle. AFE, reason adjacent angles on a straight line. Oh, it was a mistake. Okay. Okay. Because this was given because they put a block there. Do you agree, Arian? But on the other side, let me take out this F. I put it there. Let me put it here rather. On the other side, we didn't get a block. So we can't just assume it as 90. But we know this is a straight line, right? So if angles on a straight line are equal to 180, then the one next to the 90 has to be 90 as well. Does that make sense? That's the only way. Okay, you're welcome. That's the only way we can prove that that is 90. Okay, so the sooner, oh yeah, total area, I'm getting this. Guys, my brain is off today. Thank goodness for SPA and people like SPA. This whole class actually. Total area. I didn't answer the question. Our whole teacher didn't answer the question, guys. Total area is 48 plus 12, which is 60 meters squared. Then we are done. Oh my goodness. There we go. People take other screenshots again with the total area. All right. Let's hope my brain locks in this time. I'm tired. It's been a long week. Okay, are we all good with our screenshots? Can I move on? There we go. Thanks, Leachilwe. Okay, let's do one with the parallelogram. Let's go with the parallelogram. Anybody remember the formula for area of a parallelogram? Anyone? It is also base times height. The only thing is we need to remember to use the correct height. Right? Great. Now, what is my base in this case for this parallelogram? My base is, that's the base for the whole parallelogram. It's 8. Okay. The base is 8. Now, just to be safe, okay, I need us to declare, or actually for you guys, I think we're struggling a bit to see the base if it's on the other side. I know you guys are looking at DE. Now, if you are having doubts and you want to use the base where you can see that the height is perpendicular. It's actually also perpendicular here. Can you see this? 90 degrees. But if you are having doubts and you want to use this one, just make sure you first declare it before you use it. So you can go ahead and say DE is equal to GF, which is 8 meters, because opposite sides of a parallelogram are equal. Then you can use it. So it's 8. And what's my perpendicular height in this case? Your perpendicular height is 4. That was easy enough. So my total area for this parallelogram is 32 meters squared. Okay. Can we have a thumbs up, thumbs down on this one? I'm pretty sure everyone is with me on this one. Okay. Great, great, great stuff. And now we move on to the other one that we haven't done yet. What shape is this called again? There's only one pair of parallel sides that are opposites and parallel. It's a trapezium. Now, does anyone remember in the chart? Let's see who remembers the formula for area of a trapezium before I write it down. Let's see who's going to be the one who remembers what the formula is. There's a bunch of measurements that they have given us there. Let's see if we remember. Nice, Pa. I know, I like how Pa's times is so like unique, special. Nice, guys. A lot of you actually remember. A lot of you are probably just typing still, but I know you all remember. So the area of this is half of the sum of side A plus B times the perpendicular height. Do we have all of the information that we need here? You always need to start there when you're doing these things. Is my diagram complete with all the information I need to work out this area? Yes, it is. Now let's get going. What is side A? Side A is how much? Side A is? There is no 10 over there. Oh, there is a 10, but that's the wrong side. Okay, remember when we say side A or B, we're talking about the sides that are parallel. Okay, so it's never going to be these sides that are on our sides. That sounds terrible, but you get what I mean. It's always the ones that are parallel with one another. Okay, so that's easiest. Even if they turn this around, which they will in a test, trust me. If they turn this shape around and they make it vertical, you look for the two sides that are parallel. Those are the sides you're working with. So that means side A can be 24, which means side B will be 15 times my perpendicular height, which is what? Which is 8. Great. Now you guys have calculators, but I'm going to pretend I don't here. And I'm going to first add these guys in the middle. Okay, so 24 plus 15 is 39. So half of 39 times 8. Let's hear. I know this is going to be a decimal because of that 39. Oh, no, it's not. It's not. Because you can half. Yeah, I get it. 156, and my unit is it 56? Oh, okay. I was going to say, is it 56 or 57? Our unit is centimeters. Thank you. Squared. Thumbs up, thumbs down. The only thing to remember here is the correct sides to use, which are the ones that are parallel. Wonderful. Wonderful, wonderful. Okay, now I want us to look at the area of a kite. Woo, area of a kite. Now I'm gonna have a little bit of a why not? Hey bro, why not? Now guys, do you agree that so far when we had a complicated shape, oh, you mean the trapezium? Ah, it's easy to remember, man. It's easy to remember. You're gonna get used to it. As long as you remember, you are adding the parallel sides, half of that times height. It's like a triangle, but like with two sides. You get what I mean? Okay. Now, so far, we've been dividing our shapes into two separate ones. Now, ordinarily, if I didn't have that formula for area of a kite, what would I have done? What would I have done? If I didn't have that formula for area of a kite, I want to show you guys where that formula comes from. Just for enrichment purposes, for interest purposes, you would have separated them. Thank you. You would have separated them. Do we need to use 4 triangles though? You could have separated them into how many triangles? Into 2 big triangles. Do you guys agree? We agree. So for my case, I want to separate them into this triangle and this triangle. Do I agree, or rather, do you guys agree with me that you could have separated it the other way as well? You could have separated into triangle ABD and BCD. Does that, you agree, right? But for this purposes, because I'm showing you a proof, okay? In grade 10, well, from grade 10, you're going to have to start doing proofs. So you need the scale, all right? So I'm going to separate it into that. So for the area of a kite, I would have said the first one would have been half of my base. What is my base in the first triangle? Triangle ABC. What would the base of that have been? Now we're using letters because we don't have numbers, right? What would the base of that be? CA or AC times the height. What is the height, perpendicular height of that triangle? Acon. What is the height of that triangle? Look carefully. Well, in the yellow triangle, the perpendicular height. If my base is AC, then my height is BE, right? So that's triangle 1, and I would have said plus half of, what is my base for the blue triangle? My base for the blue triangle, AC again, times the perpendicular height, which is what? Perpendicular height, which is DE or ED. Okay, right. What do these two things have in common? Those two formulae that I have written down now. What do they have in common? What do they have in common? They have the AC in common. Okay, I want to mute here so that you guys can't accidentally unmute. They have the AC in common. They don't only have the AC in common. There's something else that they have in common. What is that? No. I'm going to give you a big hint now. We are going to be doing something to do with algebra. I'm talking about the formulas, guys, not the shape. Don't look at the shape. Let's look at the formulas here. Okay. The half. Wonderful, Bulela. So the half AC is the same as the half AC. What do we call it when two terms have the same thing in common? It's even in the word that I just said now. What do we call it? Does not like terms. We cannot add these. Do you agree? Because of that BE and ED, we cannot add them. No, it's not congruent. Think algebra. Think algebra. I have two terms. Let me write them in other numbers here. If I have 2x plus 8x squared. Ha! Alice is going somewhere. Factorization. What type of factorization? The specific type here. It's a specific type. Pusisiwe, is your hand up? Is it legit up so I can unmute you? Or is it a mistake? Which type of factorization, Alice? I think you are a common factor. So half AC is our common factor. What do we do with common factors? What do we do when we find a common factor? We don't add. There's a reason we had to identify. We take them out. We take them out, Jason. Thank you. So I'm going to take out half of AC. Now, you need to write what's left over, right? In term number 1, what is left over after you take out half AC? It is BE. Plus, in term number 2, what is left over after you take out half AC? ED. But do you agree that BE plus ED is just what? BE is just the whole BD. So that's how we get to our formula of half AC times BD. Do you guys like proving stuff? We just proved a formula. Okay, do we understand that proof, guys? Thumbs up, thumbs down. Why not? Is it difficult? It's not that difficult. You're going to be doing this a lot, trust me. You're going to be doing this a lot. But do we understand, though? That's what I want to know. That just means, Enhle, you take simple concepts that you know, and you prove a big one. Okay, Marlene says, please explain the second last step. This one. Okay. And that's fine, Lachlo, but do you know that proofs are like 12 marks in a paper? So the sooner you learn how to prove stuff, the better for everyone. Okay, the second last step. So, Marlene, listen, né? If you had, let's say you're doing algebra, and you have 2xy plus 4x squared minus 8xyz. And I say to you, take out a common factor. First, we started with numbers, right? I'm pretty sure you know what factors are. So what do 2 and 4 and 8 have in common? What can you take out? A 2, right? Okay, guys, I'm going to need you to answer step by step because I am explaining to someone, right? I'm explaining to someone. I'm only talking about 2 and 4 and 8. Which number can you take out of those three? A 2. There we go. A 2. Okay. Now, what do the variables have in common? Okay, I have an xy here. I have an x squared there. And I have an x over there. They all have 1 x. Do you all agree? They all have 1 x. So I have now factored it out. Now you need to write what is left. Now if you, for the first term, took out 2 and x, what's left there? A y. Okay, and the plus we get from the original symbol that was there. If you took out 2 from 4, what's left? from 4 if you took out 2. Thank you. 2. And we originally had 2 x's here, but I just took out 1. So what's left? 1x. And then my symbol is a minus. From 8, take out 2. How much is left? 4. And I just took out x from this whole series here. So what's left? Y and z. So from that concept here, we said both of these have a half and they have an AC. So I took out half and the AC. From the first term, after I took out half and AC, what was left? It was BE. Does that make sense? And then I had a plus, but the plus was already there. And I took out half AC from ED, so that's all that's left. But if you look at your sketch, BE plus ED is just the whole BD. Does that make sense? Wonderful. So the sooner we learn to like proofs, the better. Now that I have enriched your minds, your lovely minds, let us figure out let us figure out the area of this kite. Oh my gosh, I almost said triangle. That took so long. This kite. Okay. So it's just half of the 2 diagonals. So half of AC times BD. Great. How long is... Now that 5 centimeters is confusing me. I don't know if it's the whole diagonal or if it is just... Oh, 90 degrees. Yes, it's the whole diagonal. The whole AC is 5 centimeters. Okay, so we know the whole AC is 5 centimeters. Right. Now, how are we going to find BD? How are we going to find BD? Any ideas here? This is actually much more complicated than it looks, but any ideas? After I grilled your minds, I'm going to grill it one more time. Just one more time. Find BC. That is a lovely idea. That is a lovely idea, Leachilo, and that's exactly where we have to go. So let's first go and find BC. And now we're going to find BC, guys. It's on the side over here. Look there. BC is over there. How are we going to find BC? That is definitely Pythagoras. So AB squared plus BC squared is AC squared. Okay. AB is 3 squared. BC is what we're looking for. And AC is 5 squared. Okay. That means BC squared is what? 25 minus 9 this time, which is 16. Tell me how much BC is, please. Therefore, BC is equal to 4 centimeters. Great. Now is BC going to help us? We were definitely supposed to find BC. But how is that going to help us find BD? And remember what I said? They never give us a piece of information that we're not going to use. There's a reason they gave us this guy. Someone said BC is equal to DC. That's true, 4 centimeters. But DC doesn't help us still find BD. Right? But why did they put that 60 there? What type of triangle is BCD? An equilateral. So actually, Leachilo's piece of information does help us. We know that adjacent sides of a kite are equal. So BC is equal to DC. Okay, but if that's the case, that means that angle is also 60. And if two angles are 60, that means this is an equilateral triangle. Oh, I really went for your brains today, didn't I? So I can say that means that angle CBD is also 60 because they are angles opposite equal sides. All right, which then means BCD is 60 because of angles in a triangle. They need to add up to 180. So that means this is an equilateral triangle. And if that's an equilateral triangle, then BD is how long? BD is how long if this is an equilateral triangle? Therefore, BD is also 4 centimeters. Okay, now we have everything we need. So I can write here area is half of AC times BD, which is half of 5 times 4. What's half of 5 times 4? Half of 5 times 4. That is equal to 10 centimeters squared. Woo!